Welcome to the first, and hopefully for you, only episode of making a physics video to get another grade in the gradebook. I'm your host, Ethan Hunter. Today we will be doing a very common problem in the world of physics, specifically examining a car driving off a cliff. The problem. A car is traveling at 27 meters per second. It goes off a cliff that is 73 meters tall. How long is it in the air? What is the total distance in the x direction, or how far does it go? And what is its final velocity when it hits the ground? Cars really seem to drive off of cliffs a lot in physics problems. Makes me wonder how often they actually do in real life, though. I just got an idea. Maybe they should teach a section in driver's ed called How Not to Drive Off a Cliff. In any case, let's focus on the actual problem. First, let's write out our initial information we know. We know that v of x equals 27 meters per second. We also know that y equals negative 73 meters. And you may wonder why I did y equals negative 73 meters. I mean, if we go back to the actual problem, it says it goes off a cliff that is 73 meters tall. Why negative 73? Well, the answer is that in physics, it's very nice to think of the car, the point where the car starts, as the origin, so 0, 0. And it's nice to think of where it ends up as wherever it ends up. Since the car goes down 73 meters before it hits the ground, we think of this point as x, however far it goes in the x direction, negative 73. And for that reason, our y value is negative 73 meters. Next picture. We have a car going off a cliff and then falling to its death. Again, we have 73 meters right there because that's how far it goes. And right here, this car, it doesn't really work in the animation, but it is going a constant velocity of 27 meters per second because this is a magical perfect world where people still die, but there is no physics. Well, friction. That kind of shows how physics people have their priorities. So, we need to find VFY as our first thing. Some of you might wonder, why don't we just solve for time? Solving for time is a very, very good solution in physics. It's usually the solution you want to use. But solving for time, when you only have the acceleration and distance, and the initial velocity, is kind of a pain. It's just not very fun to do. So, instead, we're going to solve for the velocity, final velocity in the y direction, since that's fairly easy. It's also nice to do this because we will need that for part C, where we have to find the just the final velocity in general, or VF. And we can use this for just one other step to get T. So what equation of motion do we want to use? Well, let's first start out by writing out which information we have so far. So we do have acceleration in the y direction. We do not have time, so we can put a cross through that. We have the initial velocity in the y direction. We have the total distance y falls, and we're trying to find this. So let's write out our equations real fast so we can figure out which one we should use. We have y or x. All of these can be redone as x or y. So y equals v0y times t minus plus a times 1/2 times t squared. Okay, we also have that y equals v0y plus vfy, the final y velocity over 2 times t. So the initial velocity of y plus the final velocity of y over 2 times t. And that only works if the acceleration is constant. So if the velocity is either the same the entire way through, or we know that the acceleration is the same amount per second throughout the entire thing. We also know that the final velocity equals the initial velocity plus acceleration times time, and that the final velocity squared equals the initial velocity squared plus 2 times acceleration times y. And that's kind of a weird one, but it's actually the one we want to use, since we know that the velocity in the y direction is 0, the initial velocity in the y direction is 0, and we have all of these things. We have y, we have a, we have 2, well, obviously we have 2. We can solve for this. So what do we do to solve for this equation? Well, first, we can do the square root of 2ay equals velocity y, final velocity, not squared, because we just did a square root. And actually, it's plus or minus, so plus or minus the square root of 2ay equals the final velocity of y. And why is it plus or minus? Well, just whenever we do square roots like that, it's usually a good idea to do plus or minus and then decide at the end which it should be. Since in this case, well, there's no real way for a square root to be negative, but we know that the final y velocity, since the acceleration, which is gravity, is negative, we know that the final velocity should be negative. So let's plug in some values to this. We have that plus or minus square root of 2 times negative 9.8 meters per second squared times negative 70, what was it? Negative 73 meters. So if we multiply these all together, we get plus or minus the square root of 1430.8 meters squared over second squared equals Vy of f. So if we take the square root of that, we get about 37.826 meters per second. And in case you don't know why it went from meters squared per second squared to meters per second, it's because whatever operation you do to that, if you take a square root of a number with the units, the units are square rooted. If you square a number with units, it's the units squared. So in this case, it would suddenly be meters per second. And we know that it has to be minus in this case, since the acceleration is negative, since it's due to gravity. So Vyf equals negative 37.826. Okay, the next step is that we have to find time. So we found the final y velocity, but how can we solve that now for time? So again, we don't have time. We have acceleration, we have y, we have the initial velocity v0, and now we have the final velocity of y. Can't think today, so that's why I'm having some issues writing a letter. Okay, so these are all the things we have. We do not have time, we need to get time. So let's write out real quick all the equations of motion again. Hopefully you can figure out what the thing is. I'm just going to pause it for a second, and then we'll pop up and see what it is. Something really interesting about physics, so we have these equations here, is the number of different ways you can do things. So, honestly, now that we have all these things, we can do this equation right here, or this equation right here. But, since I'm a nerd and I like doing things the complicated way, we'll use this one up here. And it really isn't that complicated, since we know that the initial velocity in the y direction is 0. So it's would be that. Okay, so let's solve for t. So we want t to be t equals something, question mark. So let's write this out real quick. X equals velocity final of y, and we can remove the initial velocity because we know that's 0, over 2 times t. So we can divide it by 2, we'll divide it by 1/2, and by the final velocity of y. So 2y, sorry, not x, this would be y over velocity final of y equals t. Wow, so we can actually plug some stuff in and get stuff. Okay, so let's do that. Let's plug and chug and find out what t is. So 2 times negative 73 meters over the velocity final of y, which is, we calculated in the previous page, or the previous thing, is actually negative 37.826. So we multiply this all together, and guess what we get? That's like meters per second. This is negative, just to make it more clear. So we can cancel the units, and we do some magic stuff. So 2 times negative 73 is negative 146. Plug that into your calculator, divide it by negative 37.826, and we pop out that t equals 3.8598 seconds. Well, that's actually one of our answers. For part A, our question was, what is t? So we now know that t equals 3.8598. Wow, that's come on. You have to admit, this is pretty cool now. But okay, so we still have a couple more things we have to do. First of all, we need to find the distance the car goes in the extra. Okay, so we have to find the velocity, the final velocity. You can kind of think of it as, you've probably already done some vector arithmetic, so if you do like this arrow, then you do this arrow, it adds together, and you got this arrow. Yeah, so cool. It's actually not that cool, but what you can do with it is what's cool. So in this case, we want to find out the direction and magnitude. You can kind of think of it as the guy in Despicable Me, Vector, because his name is Victor. Like, I like Despicable Me. I don't know why. I have a love of it. So you kind of can imagine it as a circle. You have the angle right there, which is what angle it goes at. And then this little thing right here is the magnitude, how far away it goes. And you can also think of it as a triangle, where you have your initial thing, and you can change the angle. You can change that. So our goal is to find that. And what do we have? We have the initial y velocity, the final y velocity, which is VYF equals negative 37.826. Sorry, it's kind of hard to write on the screen while looking away. We also have VX final equals, well, x doesn't have any acceleration, so we know that it's just 27 meters per second. Also, this one is meters per second too. So, what do we do? How do we turn this into just straight that? There's this funny guy called Pythagorean. I don't know his name exactly. It's like Pythagorean or something stupid like that. He had a cult, and he didn't actually come up with the Pythagorean theorem, but we can use the Pythagorean theorem. So first we have, if you really think of it, we have like the first angle like that, and then the second vector, which is actually going to be down. So I should redraw it so it looks better. So the first angle, second angle, and that kind of looks like a triangle. So we have the x component and the y component, and then this is the hypotenuse. But it's also the magnitude in physics. So we can use the Pythagorean theorem to calculate this. So we do negative 37.826 meters per second squared plus 27 meters per second squared. And it's the square root of all this. That looks absolutely terrible. So, if you do that, you pop out the answer, which is, we can say that this equals VF. So the magnitude of velocity is, drumroll, 46.47 meters per second. And you can kind of see that's probably true, because 46.47 is greater than both of these by themselves, but both of them added together are greater than 46.47. That's a way that you can usually tell, hey, that's probably right. So we have the magnitude part. If you think, you write a vector as mag at theta blank of blank. But now we still have to find out theta. So let's go back to our good friend called SOHCAHTOA. So SOHCAHTOA. What do we have? We can really use any of these, honestly, because we have the hypotenuse, which is the magnitude. We have the opposite and we do have the adjacent. But I'm going to be honest, I prefer TOA because no one really likes TOA that much, and I have this that makes me want to love them because they aren't loved. So, what does TOA mean? So, that's our way of remembering that tangent of theta equals opposite over adjacent. I actually had to look up how to spell adjacent before I did this because I didn't want to screw it up. So if we look at this little terrible picture of the triangle thing, we see that the opposite from the angle, so here's the angle right here, it's the green part, yeah, cause remember I can do colors, so it's the green part is the angle. The side that's opposite is the y direction. The side that's adjacent is the x direction. So we really have that it equals y over x. Tangent of theta equals y over x. Before you do this on your calculator, make sure it's in degree mode. Because in like pre-calc and calc, you will have it in radian. And that's actually what the calculator defaults to when you boot it up. But in physics, we don't use radians because radians are stupid. And they're kind of annoying because they use pi and stuff. And it's not as intuitive to think of like a circle as 2 pi around. You want to think of a circle as 360 degrees around. So, make sure it is in degree before doing this. So, since we know that tangent of theta equals y over x, we also know that theta equals the inverse tangent of y over x. And if you want to know how we do that, we can say that the inverse tangent of theta equals, you're basically taking the inverse tangent of both sides, equals the inverse tangent of y over x. And since the inverse tangent of tangent, kind of like inverse, like fire and water, they put out each other, like fire boils water and water takes it out, then both of them cancel. So we just have theta equals inverse tangent of y over x. And we discover, if you punch in y and x, which I'm not going to do in front of you, discover that at equals 56.48 degrees. And I'm not going to do that for you, like show you the work, because you should be able to plug in y and x, then do the inverse tangent. In the inverse tangent, you push second on your calculator, and then tangent, then it pops out the inverse tangent for you, just because I'm a calculator nerd and I know things like that. So now we have the degree. Okay, so now we have 2 out of the 3 parts. We have that velocity f equals 46.47 meters per second at 56.48 degrees, but we still have one more part. We don't know, sorry, erasing is kind of hard. We don't know whether it's, we need to write out where the degrees are, because it's not this. It's not, we need to write out with cardinal directions where it is. So if we need to do that, we need to look back at the original thing. So we have y. What is y? Y is negative. So we can think that it's going to be down. And x is positive, which is going to be right if you think of the graph. So if you go right, it's going to be positive x. If you go down, it's going to be negative y. So if you think of the cardinal direction thing, that means it's going to be south of west or southwest. And that's the answer. Is that just the coolest thing? That's it. I hope you had a good time watching this. I hope I wasn't too stupid, and I hope I was kind of funny. It might be a little bit entertaining. So let's just write out on the next page. Well, we can write it out here anyway. So we have the velocity, that's c. We have goodness. Sorry, this. Come on, you can erase better than that. We have part B, which is that it traveled 104.2 meters 2 meters, and A, which we found that it was in the air for 3.8, that doesn't look like 3, does it? 3.8598 seconds. I should add units to that. That all seems kind of right. If you think of it, you have to check it as the 7th step. And that's all you have to do. This really isn't as hard as it looks. Okay, this physics stuff, you just got to be willing to think on your feet and think clearly, and you'll get it.